on. The next presentation is about license plates, I believe, and I will find out what are RFID license plates. We have the market development manager, Mr. Andreas Haak, if you would be so kind and make your way up here. Here we go. Awesome.
I am one of the smaller guys. So, tere to everyone. First of all, thank you to the Baltic Road Association for having me here. And thank you very much to Yuri Ratas, who said in his welcome speech that we need to gain trust into e-services and into intelligent transport systems. And that's actually what I am referring to in my presentation today, into a smart license plate. First of all, I want you to show what RFID is, because I think not everybody here knows what RFID is. So, we have an RFID-based license plate. It's a chip integrated into a license plate. It's battery-free. It's you can identify and verify the license plate in a field of 15 meters, and you do not need to maintain this license plates or the system of the license plate. We have an RFID reader and an RFID antenna, which are giving energy to the license plate, and the license plate transfers the energy and gives back data. So, what are the main features or security features of this RFID-based license plate? First of all, it's a passive, so battery-free UHF RFID tag, which means in this field we have a completely integral part of the license plate, which is the RFID plate. So it means if you break the plate, you will also break, or if you try to get out the RFID chip, you will break it, so it will be invalid. Another big point is that we have a unique number, a factory locked number, which is unique on the whole world, which cannot be copied, cannot be cloned, because this particular technology I'm referring to is safe or saved with a IES 128-bit authentication. Also, we have cryptographic authentication levels from low to high, and where we can adjust on our needs what we want to do with this license plate. Also, you can use it with every license plate, so all the regulations for a normal license plate will be held, and we can use our new license plates. So in the next, I will show you a small demonstration video. I hope this will work. Technique.
More and more vehicles are using our roads. This results in increasing demands for reliable registration and detection systems, while automated traffic monitoring demands secure, unequivocal vehicle identification. One particularly convenient, reliable solution is the radio frequency identification plate called IDePLATE, developed by Tönnjes. IDePLATE combines fraud-resistant identification technology with RAIN RFID chip technology. IDePLATE is supplemented by IDE sticks, a holographic windshield sticker. Mobile and stationary readers can be used to retrieve and verify the data stored in IDePLATE and IDE sticks, with readers, for example, at road bridges, or in future also implanted in the road. The IDE Trust software solution guarantees secure transfer of the encrypted data to authorized bodies. The RAIN RFID technology used in the systems operates with radio communication. It works regardless of the weather, and in contrast to conventional camera-based vehicle detection, it needs no visual contact. Unambiguous vehicle identification is therefore warranted in any case, even when vehicles are traveling in convoy, changing lane, or driving at high speeds of up to 250 kilometers per hour. The use of IDePLATE and IDE sticks enhances traffic safety and makes it harder to steal vehicles and number plates. Vehicle registration authorities and tax offices also benefit from reliable data and enhanced revenues. Precise detection of traffic flows is also indispensable for future-oriented infrastructure planning. IDePLATE and IDE sticks, our solution for vehicle identification and verification to make the roads safer.
Yeah, this was a small video showing the technology. So I'm right now referring to the application you can do with this technology. So first of all, there is the gate solution or the barrier solution, with which you can automatically identify and verify vehicles. You can check automatically if this is a valid vehicle which wants to enter, for example, which can be done, or a small project we are running right now, that only valid taxis who pay taxi license can get to the airport. Also, what can be done easily is automatic entrance, exit, as well as paying at parking lots. Another application is the moving traffic real-time vehicle identification, where, as we already seen in the video, we can check the identification and the authentication of a vehicle in high speed. And this offers us a solution where we can do speed checks, where we can do blacklist checks. So if there's someone stolen a car and someone called the police, it's easy for us to blacklist this car in our system, and then the next time it drives by one of the reading stations, it can be caught out by the police. Also, another big point is the traffic management. What do we do with this data? So we have a smart traffic stream control, which offers us a real-time traffic data. And we can work with this data, and we can use it, and we can give advices to other drivers and say, okay, don't use this road. I think we all knew the systems. We can automatically detect traffic jams and heavy traffic. Also, we have smart traffic planning, and therefore we can see what are the most used roads, where is the next maintenance circle, for example, we need to implement. And of course, we have a broad traffic data through availability of car-related and personal information. Then another solution we can offer, or this technology offers, is the control of stationary traffic. We can use handheld devices to use or to check the vehicles and to check if they might be blacklisted. We can easily recognize if they are stolen, and we can offer, or we can put tickets to the fine tickets with minimal human operation, because these devices automatically record the vehicle, the date, the time, as well as the position. So this is very much a pretty fine and cost-effective solution for tracking, tracing. Yeah. So what's RFID added value we have to normal license plate? First of all, of course, we have the reading at a distance point. So unlike the other systems, if we talk about normal license plates, We have a secure license plate when there is a hologram in it or something special on it. But if it's drive-by, you can easily quantify it. With the RFID technology, since it is electronically checked, it cannot be quantified that easy. Also, we have a big advantage towards other systems is the reading in adverse weather conditions, meaning if there's rain, fog, dirt, anything, we can read it electronically. It's no problem. And then, as already explained, the counterfeit protection. So since it is a really highly secure and highly technological product, it is very hard to clone or quantify this product. And also it is identifying with reliable data. So when talking about reliable data, we always have the problem that if you want to quantify a product, you can easily do that, especially while talking about license plate. For example, if we have an E and we just put a white paper on it, we can easily make an F out of it. Also a big problem with cameras, for example, if there's some dirt on it, maybe sometimes it will not show you an 8, and there's an 8 on the license plate, but it will tell you it's in B. So again, there's a problem. No problem with our system, since this is really having a modernized, and this is the next point, modernized system. Yeah, and you can use it in flowing traffic, so you don't need to stop a car to check if the license plate is valid, because you can check it while it drives by. And also it added, as already explained, some additional use cases we can use it. As already explained, there's law enforcement, like speed control, like running red lights, but also you can check expired registration and expired technical expectation, and you can also use it for toll collection. So at the end of the day, this will lead us to the benefits of RFID technology, and overall, let's say we increase road safety by reducing the number of non-registered and non-insured vehicles. We increase road safety due to reliable and traceable vehicle inspection systems. We ensure public revenues due to higher rate of registered and insured vehicles, and also higher rate of paid traffic fines. We increase efficiency of working processes due to a computerized and modern system. And we always do have a real-time database which offers us population of cars, which offers us fully traceable electronic data and anytime reporting. Thank you very much.
Thank you. Do we have any question about these cool license plates? Oh, we do have. Yes, yes, ladies and gentlemen, we have a question. There we go, this way. Can you wave your hand once again? If you could identify yourself and then present the question. Thank you.
Even I do not have RFID, I can identify myself. My name is Andreas. I work for UNEC 10 project. And I have one question. Could you please say why this kind of onboard unit, which is your solution, I think, is better than different OBUs? Because at the end of the day, I think you're not competing with the regular registration plates, but you are competing with the other OBUs, which are just collecting data or giving the information to the databases for the traffic management centers or infrastructure operators.
You are right now talking about two different things. There's these onboard units, which we are not trying to bring in.
But
onboard
I think
units
you are.
No. Onboard units are like units you have to put on your own into the vehicle. We are talking about license plates, and license plates are governmental-owned documents. And that's the main difference.
So from my perspective, you just want government to make it mandatory to use that kind of OBU for everyone. Because at the end of the day, looking from the perspective of services, which may be delivered within that solution, these are just regular ITS services we can have also with other technologies. That's why the question is, why it should be so interesting to use that technology and that solution
Yeah.
when we have a number of solutions for a number of ITS services and mobility services which might be delivered in different way,
Yeah.
especially when we are talking about the 5G roads. And in a moment we will speak about 5G internet, then maybe RFID will be sufficient for the number of services, but internet for other services. So what's the difference you see?
Yeah, first of all, when talking about onboard units, we always, or mainly talk about active RFID. Active RFID is always with a battery, and at some stage it runs low, and sometimes it needs maintenance. Our system refers to UHF, passive technology, which refers there's no maintenance, so the government can own it. And we are just preparing the government to have their own system, to use their responsibilities, not to have a private company behind it who will collect data, who will sell data. We are talking about the government. It is a government system, a governmental product, and is governmentally owned. That's what I'm referring to. I don't want to compete with V2X or something communication. I don't want to get into the private market. Our vision, or the vision of RFID license plate, are to have a governmental owned product, which a license plate is, and which refers to governmental standards, which the government decides, and that's the technology we are offering. Governmental, not private-owned one.
Thank you for that clarification, because it leads us also to the discussion about the responsibility of government for data management at the end of the day.
Yes, of course. It always leads us to the, when talking about government and data, we always need to talk about private protection issues and everything, but that's a governmental issue we need to discuss, and that's why I am so happy that Juri Ratas said we need to gain trust into e-services, and we need to gain trust into ITS, because we need all of us to see our advantages into the system to help it come through, to help us easify any governmental application.
Thank you.
Thank you.